Hello, I'm Rüzgar Torçuk, and this is my project for Phys102. The experiment aims to understand the basics of magnetism, how magnetic force works, what affects magnetic force acting on the wire, and how to calculate magnetic force with certain laboratory elements. Mainly, the magnetic force of acting wire is analyzed. On a wire is analyzed. There's a magnetic force on a current flowing wire in a magnetic field. This force is calculated with equation 1. Therefore, when we put a 2D closed loop in a magnetic field, we simply expect a torque. Thus, the torque is also calculated with equation 2. In conclusion, after deriving torque from equation 1, we get equation 2. The project compares the theoretical calculation, which is from equation 2, with practical measurements. Our procedure is: first, I created a rectangular loop with wire. Then, I set up for the experiment via using light equipment. Then I measured the average magnetic field magnitude on the middle of the setup. I also measured the sizes of the rectangle. Continuing, I controlled whether the setup is working or not. After this, I connected the dynamometer to system and gave the higher current. Followingly, the lower current. The results of the measurements were partly as expectation. However, they were not the same. With the parameters I set, the results were this for higher current and this for the lower current. I put the data on the graphs to analyze the data. With the graphs, it was seen that the theoretical calculations were lower than the practical measurements. Additionally, the error percentage was 51.58 for the higher current and 68.22 for the lower current. As expected, with the lower current, the magnitude of force acting on the current flowing cable is lower in both in theory and in the experiment, and error percentage higher with lower current because it gets more difficult to take measurements with lower force acting on the wire. The errors are most likely caused by insufficient sensitivity of dynamometers used, imperfect experiment setup, incorrect data measurement, simplifications, and assumptions like claiming the magnetic field uniform and is equal to average value at the middle.